Hello. Today I'm going to introduce you a wall climbing system inspired by gecko foot hair that uses magnets instead of van der Waals force. As you know, geckos can adhere to surfaces thanks to tiny microhairs that are on the tip of their feet. The hairs branch and have diameters down to 200 nanometers, and they provide adhesion by means of van der Waals force. Now on the right you have a scale-up version of a gecko hair. It is scaled 30,000 times. On the tip of the hairs, magnets are used in place of the conventional van der Waals interaction. So magnetic hair is simply an analogy based on two assumptions. One, that the structural properties of gecko foot hair are scalable, and two, that the magnetic and van der Waals force are exchangeable. And I am also assuming that the structural properties and thus the characteristic shapes, such as this arc shape and this triangular spatula, are not casual but play a role in the so-called efficient gecko walk. Now the question is, are van der Waals and magnetic force exchangeable? To answer this question, let's compare both forces. This graph shows the force-distance relation of an object-plate system. The x-axis is the normalized distance d by the object's radius r. The y-axis is the normalized attractive force between an object and a plate. The dots correspond to a cylindrical magnet. The dashed lines correspond to a van der Waals predicted value according to Stokes. Now we can see two clear behaviors: short range and long range. In the short range, both forces decay slowly, but as soon as the distance d becomes comparable to the radius r, a sudden switch of decay rates happens. The forces seem to behave similarly. Now let's go back to magnetic hair schema. As we have seen, the hypotheses seem to be okay, so now we know that magnetic hair might work. The following question is, do we need this? We can better see that by comparing magnetic hair against existing climbing systems. So summing up, gecko uses van der Waals, submicrometer structures, and is very energy efficient. And magnetic hair uses magnets, it's centimeter size, and we need to know how efficient it is. This is a product comparison matrix that compares four devices: gecko, gecko tape, magnetic hair, and IB magnet. IB magnet is a device invented in 1986 that uses the concept of preventing negative work to realize, in theory, effortless attachment and detachment. 3 points. Let's focus on 3 points. Cost. From the four devices, magnetic hair is the cheapest to make, and it is the cheapest on a per device basis and on a generated gram of adhesion basis. Compared to IB magnet, magnetic hair can be used on round surfaces. IB magnet cannot. Now let's take a look at the concept of performance coefficient. I want to compare devices on an energy efficiency basis, but this is difficult to do, so I use the performance coefficient as an indirect measure of efficiency. If I define P as the coefficient between the peak detachment force that a device requires to detach from a surface successfully and the maximum supported load, this is the load capacity, I have a measure of how good my device is. As we will see later, the efficiency of magnetic hair is unmatched for a device of its size.